Hello students. So we are going to discuss Max paper 2 advance dated 7/7. Okay. So we'll start with question number 35. Let f of x be a real valued function, a real even valued function, and g of x be an odd real valued function, such that f of x plus g of x is equal to e raised to x plus 1 upon x plus 1. F of x is even and g of x is odd. We have to find the fractional part of f of 0 plus g of 2. Now, putting x as 0 in the equation, we will get f of 0 plus g of 0 is equal to e raised to 0 plus 1, that is. Now, g of 0 will be 2. Sorry, g of 0 would be 0 since it is an odd function. Therefore, f of 0 will be 2. Now we want g of 2. So in the given equation, let us put x as 2. So we will get f of 2 plus g of 2 is equal to e raised to 2 plus 1 upon 3. Now in the same equation, we will put x as minus 2. Now if you put x as minus 2, we will get f of minus 2 plus g of minus 2 is equal to e raised to minus 2. It will become minus 1. Now what is f of minus 2? F of minus 2 will be same as f of 2 and g of minus 2 is minus g of 2. So if we subtract this equation, this gets cancelled. Now since g of minus 2 is minus g of 2, this will become 2g of 2 is equal to e raised to 2 minus 1 upon e raised to 2. 1 by 3 plus 1, that will become 4 by 3. So what would be g of 2? G of 2 would be e square by 2 minus 1 upon 2e square plus 2 by 3. Now coming to what we want, the fractional part of f of 0 plus g of 2. This will be equal to f of 0 we got as 2. G of 2 is e square upon 2 minus 1 upon 2e square plus 2 upon 3. Now fractional part is a periodic function with period 1. So fractional part plus any integer is going to simply give you fractional part of x, where n is any integer. So here consider this as x. So x plus 2, this will simply become fractional part of e square upon 2 minus 1 upon 2e square plus 2 upon 3. Now consider the number e square. If you approximate e to be 2.7, then e square will be approximately 7.29. Now in order to make this number less than 1, what we will do? We will subtract and add 6. So this will become 3 plus e square minus 6 upon 2 minus 1 upon 2e square plus 2 upon 3. Again, using the periodic property, this will become fractional part of e square minus 6 upon 2 minus 1 upon 2e square plus 2 upon 3. Now see, approximating these values, what would be e square minus 6 upon 2? So it is 7.29 minus 6 upon 2. This is 1.29 upon 2, which is approximately 0.645. So this is approximately 0.65, let us say. What about this? This is 0.66. 1 upon 2 e square, again e square being 7.29. This would be 14.6. Let us take 14.5 if you approximate it. Again, these are all approximate value. This will become 10 upon 145. 2 upon 29. 0.0, it will become 229. 6 or 2979. It will be approximately 0.07. So if you see this number is a number between 1 and 2. So the fractional part of this would be e square minus 6 upon 2 minus 1 upon 2 e square plus 2 by 3. Since it is a number between 1 and 2, the fractional part of this becomes the whole number minus 1. So this will be e square minus 6 upon 2 minus 1 upon 2 e square minus 1 upon 3. This is going to be the fractional part of this number. None of the options match, so this is option D. None of these. Option D, none of these. Okay, this was question number 35. Coming to question number 36. The equation of line passing through 111 and perpendicular to the line of intersection of the planes. So two planes are given P1, P2, and the line of intersection, let us call this line of intersection L1. Now the line which we want is perpendicular to this line and it is passing through 111. So we'll find the equation of L1 first. P1 is x plus 2y minus 4z is equal to 0, and P2 is 2x minus y plus 2z is equal to 0. Now vector parallel to L1, let us take B bar. B bar would be N1 cross N2. What is N1? N1 is a normal vector to plane P1, let us say. So N1 is I plus 2j minus 4k, and N2 is 2i minus j plus 2k. So this becomes I, j, k, 1, 2 minus 4, 2 minus 1, 2. Now expanding this, we will get I times 4 minus 4 minus j times 2 plus 8 plus k times minus 1 minus 4. This is minus 10j minus 5k. So this is a vector parallel to L1. Now we want a point on L1 and we know that point, see both the planes pass through the origin. So 0, 0 is a common point to the planes. So it has to lie on L1. So 0, 0, 0 lies on L1. Therefore, what would equation of L1 become? Equation of L1 is A bar, that is a 0 vector, plus T times B bar, that is minus 10j minus 5k. This is the equation of L1. Now L1, and we have a line L, which is perpendicular to L1 and it is passing through 1, 1, 1. Let us take this point as A. Now if I take this point as B, now since B lies on L1, B will be of the form 0 minus 10t minus 5t. Now what would be BA bar? BA bar would be I bar plus 1 plus 10t j bar plus 1 plus 5t k bar. Now BA bar is perpendicular to line L1, therefore BA bar dot B bar should be equal to 0. Now what is B bar? B bar is this minus 10j minus 5k. So you will get 1 into 0 plus minus 10 into 1 plus 10t plus minus 5 into 1 plus 5t. This will be equal to 0. Now dividing by minus 5. This will be 2 plus 20t plus 1 plus 5t is equal to 0. 25t is minus 3. So t will become minus 3 by 25. So what would be B? B is 0, comma, minus 10t minus 5t. So B will become 0. This is 2 upon 5. This is 6 upon 5. And this is 3 upon 5. So this is the point B. Now A point we already know A is what 1, 1, 1. So with this we can find the equation of the required line L. Equation of L. So I will use the formula x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1 is equal to z minus z1 upon z2 minus z1. So this will be x minus 1 upon minus 1, y minus 1 upon 1 by 5, z minus 1 upon minus 2 by 5. So if you multiply the denominator with a minus 5 for all this, you will get y minus 1 upon minus 1, z minus 1 upon. This is the equation of L. This is option A. Okay. Coming to question 37. Determine the value of the product AB for which the system 3 minus 2 1 5 minus 8 9 2 1 A x y z is equal to B 3 minus 1. So it's a non-homogeneous linear equation system. So for the condition, what is the condition for infinitely many solution? Delta is equal to delta x is equal to delta y is equal to delta z is equal to 0. So this condition is going to give us A and B. So let us take for delta first. So we have 3, 5, 2, minus 2, minus 8, 1, 1, 9, A. This will be equal to 0. So this is 3 times minus 8A minus 9 plus 2 times 5A minus 18 plus 1 times 5 plus 16. This will be equal to 0. This is minus 24A minus 27 plus 10A minus 36. This is plus this is 21 equal to 0. So this is minus 14A minus 27 minus 36 minus 63 minus 63 plus 21 is minus 42. So A we will get as minus 3. Now for B we will use any of this delta x, delta y, delta z. Let us take delta z equal to 0. What is delta z? This is 3, 5, 2, then B1, B2, B3, and here you will write a D1, D2, D3. This should be equal to 0. Now solving this, we will get 3 times 8 minus 3 plus 2 times minus 5 minus 6 plus B times 5 plus 16 is equal to 0. This is 15 minus 22 plus 21B is equal to 0. This is minus 7, 21B is 7, B is 1 by 3. So AB got minus 3, B is 1 by 3. So AB will be minus 1. Option B. Coming to question 38. Let A bar, B bar, C bar be three mutually perpendicular unit vector. A unit vector R bar satisfying the equation B minus C cross R cross A plus C minus A cross R cross B plus A minus B cross R cross C is equal to 0. So A bar, B bar, C bar are three mutually perpendicular unit vectors. So I'm going to take A, B, C as I, J, K. Let us assume them to be the basis vectors. and R bar is a unit vector. So we know R bar can be represented as a linear combination of the basis vectors I, j, k. Magnitude of R is 1. So x square plus y square plus z square is equal to 1. This we know. Now coming to the equation which they have given. So b minus c j minus k cross r cross I plus k minus I cross r cross j plus I minus j cross r cross k. This is equal to 0. Now using the definition of vector triple product, so this will be a linear combination of r bar and I bar. So this would be j minus k dot I, and this would be j minus k dot r plus this will be linear combination of r bar and j bar. This is k minus I dot j minus this would be k minus I dot r plus r bar and k bar. This is I minus j dot k, and this is I minus j dot r. So what will this become? See, I dot j, I dot k, these are all 0 because they are perpendicular vectors, we know. So we are, this is also equal to 0. So we are left with, okay, we can directly write this j dot r. What would be j dot r? That would be y. K dot r would be z, y minus z I bar plus z minus x j bar plus x minus y k bar is equal to 0. Now this is a 0 vector, which means and ijk are linearly independent system, so y minus z should be equal to z minus x should be equal to x minus y should be equal to 0. With this condition, we get x plus y plus x equal to y equal to z. Now square root of x square plus y square plus z square is 1. That is 3x square is 1. So x is plus or minus 1 by root 3. So what would be r? R is plus or minus 1 by root 3 I plus j plus k. Now we know this is nothing but a plus b plus c. So option A is the right one. This is question number 38. Coming to 39, multi-correct. Which of the following options are correct? So we have to check option by option. If A and B are skew symmetric matrix of same order, then AB minus BA is skew symmetric. Now A and B are skew symmetric, so A transpose is mine. Now checking for AB minus BA. AB minus BA, the whole transpose would be AB transpose minus BA transpose. This becomes B transpose, A transpose, the reversal property of transpose. B transpose is minus B, A transpose is minus A. So this becomes BA minus AB. So you can see it is skew symmetric. So first option is correct. Coming to option B, if A is symmetric, so A transpose is equal to A. Then B transpose A, B is symmetric. So let us take the transpose of this. So this would be B transpose, A transpose, B transpose, a transpose, that would be B. Now we know A transpose is A, so this becomes B transpose A, B. Therefore, it is symmetric. C option. The matrix which commute with A 1101 is always symmetric. So let us take a general matrix B. Now since a matrix is commuting with A, it has to be a 2 by 2 matrix again. AB and BA both exist, so it has to be a 2 by 2 matrix. And what is A? A is equal to 1, 1, 0, 1. So they commute, which means AB is equal to BA. A is 1, 1, 0, 1 into B is A, B, C, D is equal to B, that is A, B, C, D into A, that is 1, 1, 0, 1. Now solving this, we will get A plus C, B plus D, C, D is equal to, this is A plus B, C, C plus D. So equating this, we will get A plus C is equal to A, B plus D is equal to A plus B, C is equal to C, D is equal to C plus D. So we'll get C equal to 0. From here you will get A equal to D. C equal to C. From here also you will get C equal to 0. So using all this information, we will get B is A, B, C is 0, D is same as A. Nothing more can be concluded about B. So you see B transpose is not equal to B. It is not going to be always equal to B. Therefore, it is false. They are not always symmetric, not equal. D. All positive even integral power of a skew symmetric matrix are symmetric. This we know, A raised to n. If A is skew symmetric, A raised to n. If n is odd, then it is skew symmetric. And if n is even, it is going to be symmetric. So for even, a skew symmetric matrix is going to be symmetric. So D is correct. So option A, B, and D. This was question number 39. Question number 40. If the maximum and minimum value of the determinant 1 plus sine square x cos square x sine 2x sine square x 1 plus cos square x sine 2x sine square x cos square x 1 plus sine 2x. Now the maximum and minimum value of this determinant is alpha and beta. So let us simplify this determinant. So in place of C1, we will write C1 plus C2 plus C3. What will this become? 2 plus sine 2x cos square x. Then this also will become 2 plus sine 2x 1 plus cos square x sine 2x. This would be 2 plus sine 2x cos square x 1 plus sine 2x. So we'll take 2 plus sine 2x common from the first column. So we will have 1, 1, 1 cos square x 1 plus cos square x cos square x sin 2x sin 2x 1 plus sin 2x. Now in place of R2 we are going to write R2 minus R1, and in place of R3 we are going to write R3 minus R1. So this will become 2 plus sin 2x. R1 is going to be as it is, so 1 cos square x sin 2x R2 minus R1. So this will become 0, this will become 1, this will become 0, this will become 0, 0, 1. So expanding using column 1, 2 plus sin x, this is 1 into 1 and the remaining is 0. So the simplified form of the determinant is 2 plus sin 2x. So what will be the maximum value? That will be when sine is 1, so that is 3. Minimum value is when sine is minus 1, that is 1. Now coming to options, A1 alpha plus beta raised to 99. So this is 3 plus 1 raised to 99 is 1. So this is 4. Option A is correct. B1 alpha cube minus beta raised to 70. That is 3 cube 27 minus 1. This is 26. So B is correct. C1 alpha raised to 2n plus beta raised to 2. This is 3 raised to 2n plus beta raised to 2n is 1. This is always even for integer natural number, because this is always going to be odd. Any higher power of a odd number is always going to be odd plus 1, so this will be even. D1 a triangle can be constructed having sides alpha minus beta. So alpha minus beta is 2, alpha plus beta is 4, alpha plus 3 beta is 6. This is not possible, because for a triangle sum of two sides should always be greater than the third side. So here the sum of these two is equal to the third side, so not possible. So A, B and C are the correct options. 41, let f of x is equal to 1 by x. G of x is equal to 1 upon 4x square minus 1, and h of x is equal to 5x upon x plus 2. Okay, now the function kx is equal to h g fx. If the domain and range of kx are r minus a1, a2, a3, an, and r minus a respectively, the r is the set of real numbers. We have to check which option is correct. So we'll first find the domain and range of kx. So we'll first find the function kx. First, what would be g of fx? G of fx would be g में f substitute करेंगे. This is 1 upon x whole square minus 1. If you simplify this, this is x square upon 4 minus x square. What is h of g of fx? So for this, in h of x, we are going to substitute g of fx. So it will become 5 times x square upon 4 minus x square. X square upon 4 minus x square plus 2. So solving this is 5x square upon x square plus 2 times 4 minus x square. Now domain of this function. So it is going to be r minus all the values which we cannot put. So we'll start with fx, because x is going to first, x will first go into f of x, and then the output will go into g, and then the output will go into h. Okay, so what you have to do is first you have to find the domain of f of x, then you have to find the domain of g of fx, and then you have to find the domain of h g f x. And the intersection of these three is the domain of this function. So x cannot be 0 first, because f of x will not take the value. Now g of fx, again denominator cannot be 0, so x cannot be plus or minus 2. H g fx, so we'll come to here. So here x cannot be plus or minus 2 root. This is going to be the domain of the function kx. And let us find the range. So for range, we will take hg of fx. Hg of fx is what? 5x square upon 8 minus x square. So we will take this as y. So 5x square is equal to 8y minus x square y. So this will become x square times y plus 5 minus 8y is equal to 0. Now delta should be greater than or equal to 0. So b square minus 4ac greater than or equal to 0. So this says y is less than equal to minus 5 or y is greater than or equal to 0. Now always make sure the endpoints are included. So can this expression be 0? That is, can y be 0? When will y become 0? So y becomes 0 when x is 0, but x cannot be 0 because 0 is not part of the domain. Can y be minus 5? So you take this 5x square on 8 minus x square is equal to minus 5. So you will get x square is equal to minus 8 plus x square. Minus 8 is 0. So this is never true for no value of x. This is true. In fact, this function approaches minus 5 as x approaches 2 root 2. That is when the denominator approaches what? Infinity, right? So minus 5 and 0 cannot be the output. Minus 0 was corresponding to x equal to 0. Minus 5 were corresponding to x is plus or minus 2 root 2. What about plus or minus 2? That also cannot be in the domain of this function. So if you put x as plus or minus 2, you will get 5 into 4, 20 upon 8 minus 4. This is 5. So 5 also cannot be in the output. So what is the range? A range is all real number except. So we have now concluded that it cannot be equal to minus 5, it cannot be equal to 0. So r minus the minus 5 to 0 minus the integer 5. This is the range. Now coming to the option n plus summation of I is equal to 1 to n a n. Well, what is n? So the domain they are representing as r minus a1, a2, a3 up till an. So n is a number of values that are excluded from the domain. So that is how many? 5 values. So this is 5 plus sum of all those values. And sum of all those values is what? This is 0. So this is 5. So option A is correct. The number of integers in set A. What is A? Now range they are specifying as R minus A. Now, so this is A. Now what is the number of integers here? So you have minus 5, minus 4, minus 3, minus 2, minus 1, 0 and another integer 5. So total 1, 2, 3, 4, 5, 6, 7. So number of integers in A is 7. So option A and D. So this was question number 41, multi-correct type. Now next section is integer type. Question number 42. So first question they are saying, for any real number A, box S is the greatest integer less than equal to x. Box X is greatest integer less than equal to x. So we have number of real solutions for the equation magnitude of 2x minus greatest integer of x should be equal to 4. So we know x minus greatest integer of x is the fractional part of x. So this becomes x plus fractional part of x is equal to 4. So x plus fractional part of x is equal to 4 or x plus fractional part of x is equal to minus 4. Now you have to do it by trial and error and it is very easy to locate the answers. In fact, fractional part of x is 4 minus x. Now, for this, what is the range in which you have to select, you have to try for solution is this fractional part of x is always from 0 to 1. So if that has to be the case, then what should be x? X should be less than 3 and greater than equal to 4. So between 3 and 4, including 4, you have to select which numbers will satisfy. So one number I can already see is 4. 4 plus fractional part of 4 is 4. Next number is 3.5. 3.5 plus the fractional part of 3.5 is 4. Remember, the output should be an integer 4. There is no other x's here in between that will satisfy this. So two solutions here. Here, fractional part of x is minus 4 minus x. Again, for fractional part of x to lie between 0 and 1, what is the condition for x? Minus 3 to minus 4. It can be equal to minus 4 and less than minus 3. So what are the x's? Again, you can see minus 4 is going to satisfy this. If you put x as minus 4 plus fractional part of minus 4 is 0. And the next integer, in fact, this is not the range of this. If you put minus 4, it will become 0, and the next is going to be minus 5. So minus 5 and minus 4 cannot be equal to minus 5, can be equal to minus 4. Okay, so x is minus 4 and the other value which will satisfy is minus 4.5. Fractional part of minus 4.5 is 0.5. So minus 4.5 plus 0.5 is minus 4. These are the four values that are going to satisfy this equation. Therefore, a number of real solutions is 4. This was question number 42. Question number 43. The position vector 2i plus j plus k is rotated about origin by an angle of 90 degree such that it crosses positive x-axis. Then the new position vector after rotation is alpha I plus beta j plus gamma k. Then we have to find the value of magnitude of alpha plus beta plus gamma upon root 2. So the point will be here somewhere. The vector is 2i plus j plus k. Now, see, this is not a 2D rotation. It's not a rotation done in a simple xy plane. For a simple xy plane, we know the rotation matrix we can use. But here, the rotation can be about any plane. It is done about the point origin. Now, the indication as to how it is rotated, in which direction and in which plane. For that, they are saying the rotation is such that it crosses the positive x-axis. So it crosses the positive x-axis. So it will come somewhere here. Let us take this is a bar. This has to be some vector. This vector is very important. B bar and this is C bar. Now this is a point on the x-axis. This angle is 90. Now remember, since it is only rotated, magnitude of A will be equal to magnitude of B will be equal to magnitude of C. What is the magnitude of A? If we calculate it is root 6. So the magnitude has to be root 6. So B bar, you can guess, you can find what B bar is. It has to be root 6 times I cap. So A bar we have, B bar we have, and we now have to find C bar. So C bar is what they are saying as alpha I plus beta j plus gamma k. Now what condition we can use is, let us take the angle. So we know A dot C. A dot C is going to be equal to 0. So what is A dot C? A dot C, if you do, you will get 2 alpha plus beta plus gamma is equal to 0. This we have. Now let theta be the angle between A bar and B bar, and phi be the angle between B bar and C bar. So what would be cos theta? Cos theta would be A bar dot B bar upon magnitude of A bar into magnitude of B bar. And what would be cos phi? Cos phi would be B bar dot C bar upon magnitude of B bar into magnitude of C bar. Now this is A dot B. We can find A dot B. We have vector A and we have vector B. So A dot B would be 2 root 6. Magnitude of A into magnitude of B, both are root 6. So this will be 6. So this is simply 2 by root 6. What about cos phi? Now here phi can be written as 90 minus theta. This is B dot C. So B dot C, if you do, you will get root 6 alpha upon, again this is 6. Now what is cos 90 minus theta? This is sin theta is equal to alpha upon root 6. Now what would be sin theta? We can find sin theta. Root 6, sorry. So this is 2 and this is root 6. So this would be root 2. So sin theta is root 2 upon root 6 is equal to alpha upon root 6. So alpha we will get as root 2. Now what equations do we have? We have 2 alpha plus beta plus gamma equal to 0. So alpha plus beta plus gamma will be minus 2 alpha, that is minus 2 root 2. And we have the magnitude of B is root 6, we know. Therefore, alpha square plus beta square plus gamma square is 6. Now alpha square is 2, so beta square plus gamma square is 4. Now beta square plus gamma square can be written as beta plus gamma the whole square minus 2 beta gamma is 4. So what is 2 beta gamma? Beta plus gamma we know it is minus 2 root 2. So that square is 8 minus 4. So beta into gamma is 2. So beta gamma is 2. Alpha you have root 2. And beta plus gamma is minus 2 root 2. You solve these two equations. You will get beta as minus root 2, gamma also minus 2. So beta plus gamma will become minus 2 root 2 and beta into gamma is 2. So what is C bar? It is root 2 I bar minus root 2 J bar minus root 2 K bar. So now we want magnitude of alpha plus beta plus gamma upon root 2. This is root 2 minus root 2 minus root 2 upon root 2. This will become 1. This was question number 43. Question number 44. The distance between the image of 8 minus 8, 2 in the plane 3x. So image of 8 minus 8, 2 in the plane 3x minus y plus 4z is equal to 1. And the point of intersection of the line with the plane. So another point given by intersection of the line is x minus 2 upon 3, y plus 1 upon 4 is z minus 2 upon, and this plane is a different plane, x minus y plus z equal to. So the distance between this point and this point is d, then 7d by 30. Okay, let us take this point as a and this point as b. So we have to find a and b and then the distance between them. So let's take a as HKL. Now we know the formula to find the image about a plane. So h minus x1 upon a, k minus y1 upon b, L minus Z1 upon C is equal to minus 2 AX1 plus BY1 plus C Z1 plus D upon root A square plus B square plus Z. So that is 9 plus 1 plus 16, that is 26. 13, this is 40 minus 139, so this is 3. So H minus 8 upon 3 is equal to K plus 8 upon minus 1 is equal to L minus 2 upon 4 is equal to minus 3. So what would be H? Minus 9 plus 8, that is minus 1. What would be K? 3 minus 8, that is minus 5. And what would be L? Minus 12 plus 2, that would be minus 10. So point A is minus 1, minus 5, minus 10. What about point B? So for point B, since B lies on the line, so B will be of the form 3 lambda plus 2, 4 lambda minus 1, 12 lambda plus 2. So since it lies on the plane, it will satisfy the equation of plane is equal to 5. So 3 lambda minus 4 lambda is minus lambda plus 12 lambda, that is 11 lambda. 2 plus 1, 3 plus 2, 5 is equal to 5. So lambda we will get as 0. So if lambda is 0, B will become 2 minus 1, 2. Now the distance between AB, so square root of x2 minus x1, that is 3 square 9, minus 1 plus 4, that is 16, and 12. This is 169, 13. So what is 7d by 13? That would be 7 into 13 by 13. So the answer is 7. This was question number 44. Question number 45. Consider the matrices A is equal to 2, 4, 1, 1. B is equal to 3, 2, 4, 3. And C is equal to 3 minus 4 minus 2, 3. We have to find trace of A plus trace of A, B, C by 2 plus trace of A, B, C square by 4. So on till infinity. Now, so it's a pattern in BC. Let us find BC. 3, 4, 2, 3, 3, minus 4, minus 2, 3. In fact, if you see B and C are inverse of each other. If you calculate this 9 minus 8, 1, minus 12 plus 12, 0, 6 minus 6 is 0, minus 8 plus 9, 1. So BC is 1. So the given expression simply simplifies to trace of A by 2, trace of A by 4, and so on. So this is trace of A. If you take common, this is 1 plus 1 by 2 plus 1 by 4. Now what is trace of A? Sum of principal diagonal, that is 3. This is an infinite GP, A upon 1 minus A. So 3 into 2, this will become 6. This was question number 45. Question number 46. Let A be A, B, C, D, A, B, C, D, E, F, and B is 1, 2, 3, 4, 5. Find the number of functions from A to B such that for every x belonging to A, there is exactly one y belonging to a. Y is not equal to x. F of x is equal to f of y. And xy, they both come from a. So what does this condition mean? So x and y should have the same output. And x and y are two elements from the set A. And there has to be only two of such. There cannot be another z, let us say. So this means that for every x, so let us say if A is mapped to 1, then one of the remaining 5 and only one of them should be mapped to 1. This has to be true for all the numbers. In other words, what their meaning is, we form groups of 2. Let us say this is one example, one such mapping. Let us say AB is mapped to 1, CD is mapped to 2, EF is mapped to 3. This is the type of function which they are talking about. So if you consider A is mapped to 1 and A has another partner B which is mapped to 1, there is no other element which is mapped to 1. Similarly, CD, EF. So each of the element in A is part of a pair which is mapped to the same element in B. So this is one such function. How many such functions you can form? So the process is simple. A has 6 elements. So the number of ways in which the 6 element you can divide it into 3 equal groups of 2. So we know the number of ways to do this is 6 factorial upon 2 factorial cube into 3 factorial since it is equal group. Now each of this group, so if you take one such group for example, then what are the possible mappings which you can do to B? So for each group, so it is like 3 elements you have now and you have 5 elements in B. So for the first group you have 5 choices, for the second group 4 choices, and for the third group 3 choices. This is what you have to calculate. So this is 720, 2 cube is 2. So this will become 8 into 6 and this is 60. 10s are 9s. So total 900 such functions you can make. Okay, this was 46. Coming to 47, the product of roots of the equation. Product of roots of the equation. So the equation is given by a determinant, and the determinant is 1 minus 2x1 x 1 plus x 1 minus x square. So this equation, product of the roots of this equation is what we want. Now, what kind of simplification we can do before expanding this? So I'm going to do C2 gives C2 minus C1. So C1 is as it is. What will be C2 minus C1? That would be 2x. 2 plus x minus 2 plus x. This would be 2x again. 1 plus x minus 6. This would be 1. This is 1 minus x. 3 plus x. 1 minus x square. Now what we can do, in place of R2, I am going to write R2 minus R1. So R1 is as it is, 2x 1 minus x. But 2 minus x minus 1 plus 2x, that would be 1 plus x. This would be 0. 3 plus x minus 1 plus. This is 2 plus 2x. And this is x, this is 1, this is 1 minus x square. So we can take 1 plus x common from the second row. So if I take 1 plus x common, this becomes 1 minus 2x, 2x, 1 minus x. This becomes 1, this becomes 0, this is 2, this is x, this is 1, 1 minus x square. So this is simple enough to expand now. So we will do 1 plus x bracket. This is 1 minus 2x times 0 minus 2. Minus 2x times 1 minus x square minus 2x plus 1 minus x times it is simply 1. Now expanding this is minus 2, so we will get minus 2 plus 4x minus 2x plus 2x cube plus 4x square plus 1 minus x. Now simplifying this, we have 2x cube plus 4x square. So I have taken this. For the x, if you see 4x minus 2x is 2x minus x is x. And the numbers we have minus 2 plus 1, this is minus 1. Now expanding this again, so we have 2x cube plus 4x square plus x minus 1 plus 2x raised to 4 plus 4x cube plus x square minus x. So we have 2x raised to 4, 2x cube plus 4x cube, this is 6x cube, 4x square plus x square, this is 5x square, x and minus x gets cancelled. So we are left with minus 1. So this is a biquadratic equation, S4 product of the roots. So it would be, so we'll use the constant, right? Minus 1 upon 2. So this is P. P is equal to minus 1 upon 2. So what is mod of 4P? That is 4 into minus 1 upon 2. This will be 2. So this was question number 47. Section 4, last section, paragraph type. So two paragraphs. So coming to paragraph 1. If A and B are two square matrices of the same order, determinant of A is 1, determinant of B is 2, of order 2 by 2. Okay, so we want determinant of A plus 2B. Now, the formula to expand the determinant A plus B, we don't really have a property for that. Right? So, if you see, there is a pattern here. So, generally, if you talk about determinant of A plus KB, if you take A as, let us say, A, B, C, D, and B is E, F, G, H. So what would be determinant of A plus KB? It would be A plus KE, B plus KF, C plus KG, D plus KH. Now if you expand this, you will get A plus KE into D plus KH minus B plus KF into C plus KG. So this would be AD plus AHK plus EDK plus K square EH. This would be minus BC minus BGK minus CFK minus K square FG. Now if you see AD minus BC, that will become determinant of A. From these two terms, if you take K square common, that is EH minus FG. So EH minus FG is determinant of B. Then K times all the remaining term ED plus AH minus BG minus CF. This is determinant of A plus KB. If you do determinant of KA plus B, so what would be KA plus B? KA plus B would be AK plus E, then it would be BK plus F, then it would be CK plus G and DK plus H. If you expand this AK plus E, dk plus h minus bk plus f into ck plus g. This will become k square ad plus ah times k plus de times k plus eh minus k square times bc minus bgk minus cfk plus fg. So you have k square times AD minus BC. So that is k square times determinant of A, and you have EH, this would be minus FG. That would be determinant of B plus K times AH plus DE minus BG minus CF. Now, determinant of A plus KB minus determinant of KA plus B. If you do this, then you see this term and this term gets cancelled. So you are left with 1 minus k square times determinant of A plus k square minus 1 times determinant of B. So if you take k square minus 1 common, this will be determinant of B minus determinant of A. So this is what we are going to use for both 48 and 49. So in question number 48, it is A plus 2B and 2A plus B. So K is 2. So it will become 4 minus 1 times determinant of B is 2, determinant of A is 1. So this is 3. What about 49? In 49, it is A minus 2B and minus 2A plus B. So K is minus 2 there. So K square minus 1 is the same thing. This will also be 3. So 48 is 3, 49 is also 3. This was the first paragraph. Paragraph 2. So L1 is given by R bar is equal to 2I bar plus J bar minus K bar plus lambda I bar minus 2J bar plus K bar. L2 is given as R bar is equal to 8 by 3I bar minus 3J bar plus K bar plus mu times 2I bar minus J bar plus K bar, where lambda and b are real numbers with two lines in space. A line L from the origin meets the line L1 and L2 at P and Q respective. So there is a line L. Let us take R bar. Since it passes through the origin, so it becomes the A bar becomes 0. Okay, so let us take this as A1 bar, B1 bar, A2 bar, B2 bar. Now A3 bar is 0, so it will be, let us say, T times AI bar, BJ bar, CK bar. Now L meets L1 and L2 at P and Q respectively. Okay, question number 50. Let M be a point in space and N be a point on L1. Let lambda be the value for which Mn is parallel to the plane R bar dot I minus 4j plus 3k is 1. So what is the equation of this plane? This is the vector form. So in the Cartesian form, it will be x minus 4y plus 3z is equal to 1. Now Mn is parallel to this plane, so Mn will be perpendicular to its normal. Okay, so M is given. M is 1, 2, 3. N is a point on L1. So what would be any point on L1 look like? It would be lambda plus 2 minus 2 lambda plus 1 lambda minus 1. So what would be mn bar? N bar minus m1, that would be lambda plus 1 minus 2 lambda minus 1 lambda minus 4. So this is the components of mn bar. So mn is perpendicular to n bar. What is n bar? N bar is, this is n bar, I bar minus 4j bar plus 3k bar. So mn bar dot n bar should be equal to 0. So this is lambda plus 1 times I plus minus 2 lambda minus 1 times minus 4 is equal to 0. This is lambda plus 1 plus 8 lambda plus 4 plus 3 lambda minus 12 equal to 0. So this is 12 lambda, 5 minus 12 minus 7. So lambda is 7 by 12. So we want 12 lambda. So 12 lambda will be equal to 7. This is question number 50. Question number 51. We have to find 3pq square. So for that we have to find pq, the point of intersection. Now L and L1 are intersecting. Therefore, shortest distance between them will be 0. Now, what is the formula of shortest different distance between them? So, L is A3 bar minus A1 bar dot B3 bar cross B1 bar should be equal to 0. If A3 is a null vector, so A1 bar, so this would simply be, if you put this into determinant, you will get 2, 1 minus 1, that is A1 bar, and B3 bar, okay, let us write B3 first for the purpose of simplicity. So A, B, C, A1 is 2, 1 minus 1, and what is B1 bar? 1 minus 2, 1. This will be equal to 0. So if you solve this, you will get 1 minus 2 plus minus B, this is 2 plus 1 plus C, it is minus 4 minus 1 is equal to 0. So minus A minus 3B minus 5C is equal to 0. So we will get A plus 3B. This is one equation. Similarly, L and L2 are intersecting. Therefore, A3 bar minus A2 bar dot B3 bar cross B2 bar will be equal to 0. Again, A3 bar, we can simply put the value of A2. Okay, let us write this B3 first. So A, B, C. Then you have 8 by 3 minus 3, 1. This is A2 bar. And B2 bar is 2 minus 1, 1. So this determinant value is also equal to 0. So solving this, what we will get? We will get A times minus 3 plus 1 minus B times 8 by 3 minus 2 plus C times minus 8 by 3 plus 6 is equal to 0. This is minus 2A minus 2B by 3, 18 minus 8 plus 10C by 3 is equal to 0. Now multiplying by minus 3, we will get 6A plus 2B minus 10C is equal to 0. So dividing by 3, we will get, dividing by 2, in fact, we will get 3A plus B minus 5c is equal to 0. So let us put c as k. If you put c as k, then we will get 3a plus b is equal to 5k. And for the first equation, we will get a plus 3b. A plus 3b is minus 5k. Now solving this, we will get 4a plus 4b is 0, which is a plus b is equal to 0. Now you can use this in any one equation. A is equal to what? Minus b. So if we use this in this equation, let us say we will get b is minus a. So 2a is equal to 5c. So we will get a is equal to 5k by 2 and b is minus 5k by 2 and c is k. Now forming an equation with this, we'll get 2a by 5 is equal to minus 2b by 5 is equal to c. You divide by 2, you will get a by 5 is equal to minus b by 5 is equal to c by 2. So one of the values satisfying this a, b, c we can take as, if you take this as 1, then you will get 5 minus 5 and 2. So this can be taken as one of the values or one of the DRS of the vector. So this can be taken as this. Remember, this is a norm, it's a parallel vector. So A, B, C, any proportional values we can take. So our L bar will become T times 5I bar minus 5J bar plus 2K bar. Now to find P, so P will be of the form 5T minus 5T plus 2T. Now this lies on L1. P lies on L1. So it will satisfy the equation of L1. Now what is L1? You write it in the symmetric form. So it is, one second. Yeah. So L1 can be written as x minus 2 upon 1 is equal to y minus 1 upon minus 2 is equal to z plus 1 upon 1. This is the symmetric form of L1. So substitute x as 5t, y as minus 5t, and this is 2t plus 1. You multiply with 2, you will get 10t minus 4 is equal to 5t plus 1 is equal to 4t plus 2. You take any 2 and solve, you will get the same value. So 5t is 5t, you will get as 1. So p point simply becomes 5 minus 5 and now to find q, again q lies on L2 and q is a point come to L and L. So q will be again of the form 5t minus 5t 2t. Now this we will put in L2. Now write L2 in the symmetric form. You look at the equation, so you will get x minus 8 by 3 upon 2, y plus 3 upon minus 1, z minus 1 upon 1. This is the symmetric form of L2. So substitute x as 5t, so 5t minus 8 by 3 upon 2 minus 5t plus 3 upon minus 1, 2t minus 1 upon 1. So you take anything, you take these two and solve. You will get minus 5t plus 3 is equal to minus 2t plus 1. So you will get 3t is equal to 2. T is 2 by 3. So what will q become? Q will become 10 by 3 minus 10 by 3, 4 by 3. So we have P and Q. We can find distance PQ now. PQ will be square root of 10 by 3 minus 5 the whole square plus minus 10 by 3 plus 5 the whole square, 4 by 3 minus 2 the whole square. This is minus 5 by 3, that will become 25 by 9. This is 5 by 3, again square will become 25 by 9. This is 4 minus 6 minus 2 by 3, this will become 4 by 9. So PQ square will actually become 54 by 9. This is 6. So 3PQ square will become 3 into 6, which is 18. So this was question number 51. This was the last question. So this was advanced paper 2 max. I hope you all understood.